Okay, now they want to know how much time the electron spends in the magnetic field. Sort of an interesting question. Let's just remind ourselves as the electron comes in here, it's going to get bent around and kind of follow a semicircular path going out. And the nice thing we know is that the speed of the electron is not going to change as it goes out of there. So the speed will be constant, which means if we want to know how much time it spends in there, well, we just need to know the distance of the path divided by the velocity of the path. Okay, so how can we figure some of this out here? Well, I think we probably are going to have to go back to our Newton's laws here and use our F equals ma, because from that we can figure out the force that we have on this electron. It's going to be constant. It's Q, V, B, and the angle there is 90 degrees, so we're safe on that side. That's just going to be the mass times the acceleration. Now, it's not speeding up or slowing down, it's changing direction, going in a circle, so that's just going to be v squared over r. And so then what we need to do, so let me go ahead and solve this for v, and I guess try not to make it too complicated. I'm going to move v onto the opposite side here, and I still have a q and a b here, and this r that was in the denominator comes up to the numerator, and then I get m in the denominator. So this is expression for the speed of the electron as a function of the radius, mass, q, and b, the charge in the magnetic field. Let me go ahead and substitute that back in the top equation here. I have the time is going to be equal to the distance. Well, the distance, if I call this radius here r, the distance it has to travel is just going to be pi times r. It's half a circle. And then if I divide that by the velocity, q b r over m, well, the r's cancel out, and I get a nice m comes to the numerator, pi's in the numerator, and I have q and b in the denominator. And when I plug all these numbers in, which they fortunately gave me, I actually do get the 6 times 10 to the minus 11.